My name is Sumit Sagar Hota. I am a PMRA PhD scholar, IIT Palakkad. Today we will discuss lecture 6 to 10 by Professor Ashok Desar, IIT Kanpur, for the subject Introduction to Airbreathing and Propulsion by NPTEL. Okay, this is the week 2 of the live discussion section. Okay, am I audible to all of you?
Yes, sir.
Okay, thank you. Okay, the prerequisite for this section is you should watch at least this lecture 6 to 10. Okay, let's in this section first we solve some MCQ problems and then we go for the MCQ questions, maybe theoretical, then we go for the problems. Okay, that's what the idea. Okay, eddy viscosity is a turbulent transfer of dash. Okay, the answer is very simple. Answer is C. Okay, momentum. Okay, eddy viscosity. Okay, what is eddy viscosity? What is the definition? Turbulent if you want to write down, you just write down with me because I am not going to wait for you to again write down. Okay, okay, eddy viscosity is the turbulent transfer of momentum by eddies. Okay, now what it gives rise to? This gives rise to internal fluid friction. Okay, and this eddy viscosity is analogous to which kind of viscosity? Okay, this is analogous to molecular viscosity in laminar fluid flow. Okay, so this is about eddy viscosity. So these three questions can be separately also set. Okay, turbulent transfer of momentum by eddies. Okay, so eddies can be a question, gives rise to internal fluid friction. Internal fluid friction can be one fill in the blanks question, which means eddy viscosity is analogous to what? Molecular viscosity. So these three questions can easily be set. Okay, so next question. Which among the following is the equation of Bernoulli? Okay, so the answer is very simple. Answer is A, that is TdS is equal to dH minus VdP. Okay, so this equation remembering is not important. Okay, but to know what exactly these things are, then it will be that is more important. Okay, here it's not the only enthalpy, this is specific enthalpy or enthalpy per unit mass. Okay, this is specific volume this is pressure, this is temperature, and this is specific entropy. Okay, now this is called the Bernoulli's equation. Okay, so okay, now for example, if one question can be set that for any kind of adiabatic and frictionless flow, okay, this Bernoulli's equation is identical to which kind of equation? Okay, so this can, one question can very easily, well asked question. So for adiabatic and frictionless flow, okay, for adiabatic and frictionless flow, the Bernoulli's equation is identical to energy equation. Okay, that means this is derived from the energy equation, and this is the some maybe some assumptions like adiabatic and frictionless. This kind of one assumptions are there. When these assumptions are applied, then this energy equation is reduces to our Bernoulli's equation, and which is shown here. Td is equal to dH minus vdp. Okay, this derivation, all these things you have to go through. Okay, this is already very simple derivations are there that you have to go through. Okay, for an isentropic flow, what will be the zero? What will be the which property will be zero? Okay, enthalpy, entropy, pressure, temperature. Okay, it's very simple. Its name suggests everything. Isentropic means entropy is already there in the flow. That means obviously the entropy should be zero. Okay, the answer is B. Okay, so how we know that? I will now show. Okay, so actually the entropy is not zero. Okay, the change in entropy is zero. Okay, but in the options there is no change in entropy. Options are not present. Okay, so for example, in one question will be there where one entropy equal to 0 is there and one change in entropy 0 option is also there. Okay, so then you have to choose the ds equal to 0 or delta of entropy equal to 0. That will be the correct option. Entropy equal to 0 is the wrong means wrong option. Okay, so here since there is no options are exist. Okay, so that's the reason we just choose this option. If there is also one option there, none of these, I think none of these will be the correct option. Okay, so ds equal to 0. The previous Bernoulli's equation I just applied. Okay, so dH is equal to vdp or dH minus vdp is equal to 0. Okay, this is the condition for your isentropic flow. Okay, the Bernoulli's equation. Okay, now next question. Which among the following is the Euler's equation? Okay, so very good confusion arises when Euler's equation and Bernoulli's equation came into existence. Just write down isentropic flow. Okay, it's the Bernoulli's equation. Now here which of the following is the Euler's equation? Okay, it's similar to the Bernoulli's equation, but in place of minus there will be plus. Okay. Okay. B dB plus dH equal to 0. Okay, that is the Euler's equation. Okay, these are the specific properties: specific volume and specific enthalpy. Okay, now this is identical to what? Which form of the energy equation? Okay, identical to adiabatic form of energy equation. Okay, so identical to the adiabatic form of the energy equation. Now, so very easily one question asked, it is only the adiabatic form of the energy equation. Okay, this is the Euler's equation. And what about the Bernoulli's equation? Okay, this is the adiabatic form of the energy equation. We already studied that Bernoulli's equation is the adiabatic and frictionless form of the energy equation. Okay, so this is the very small difference is there. Okay, and they can very easily confuse you. One they will add adiabatic, and another option they will write down adiabatic and frictionless, and they can ask you which one is the Bernoulli's equation or which one is your Euler's equation. They can confuse you very easily. Okay. Now next question, which among the following is the formula of momentum principle? Okay, so now momentum principle, then we just done one control volume. Let these two area will be A1 and A2. Okay, and this is the control volume. Okay, then the force applied in this area will be P1A1. P1 is the pressure at the phase 1, and this will be P2A2. Okay, let's say there is some external force is there. Okay, that is F. Okay, and because this is a momentum equation, so mv2 will be there, linear momentum, and mv1 also be there. Okay, so and here we should know this, note one thing, that A is equal to A dash by L and M is equal to M dash by L. Okay, and okay, now A dash is your meter square and M dash is your kg. Okay, and L is your meter. Okay, so now just apply the momentum conservation. I just assume that the counterclockwise will be positive. Okay, you just see the F will rotate this control volume counterclockwise, P1 and A1 will rotate it counterclockwise, P2 A2 also rotate it counterclockwise, MV2 rotate it clockwise, and MV1 rotate it clockwise. Okay, so if you just write down, if counterclockwise will be positive, then the clockwise will be negative. Okay, mv2 into mv1. Okay, so this is what the equation we get, and this is your answer D. Okay, So let's go to next question. Define stagnation temperature. Okay, what is stagnation temperature? Very easy question. Okay, okay, okay. So stagnation temperature is your temperature at zero velocity. Okay. Okay, so this is the stagnation temperature. Okay, let's go to next question. Okay, what is the viscosity of water at 30 degrees Celsius? Okay, so now this kind of question for some specific fluids like water, air. Okay, what is the density at the 30 degrees Celsius? Okay, what is the viscosity? What is the kinematic viscosity of the water, air? Okay, all these things you should just remember. Some specific fluids like methane, ethane. Okay, because these are the most commonly used fuels like kerosene. Okay, some kerosene fluids are used in your aircrafts. So in this kind of fuels, all these things, basic fuels, you have to remember their kinematic viscosity, dynamic viscosity, everything you have to just remember all these things, because this kind of question can be asked. Okay. So here only viscosity mentioned means it's the dynamic viscosity. Okay, so I also write down for air. Other things you have to see. Okay, these are most common things, so I just write down. Okay, next question. The dash section of a nozzle or diffuser is called throat. Okay, so it's very simple. Obviously it will be the minimum. These are all throats. Okay. Answer is C. Okay. Next question. In adiabatic flow, what remains constant? Okay. Obviously, if there is adiabatic flow, that means the temperature will be constant. Okay. And if temperature is constant, that means the enthalpy is also constant. Okay. Okay, and we should note that this is not the normal temperature. Okay, this is the stagnation temperature and stagnation enthalpy. Okay. Okay. Next question. When Mach number m less than 1 and flow area decreases, then what will be the condition? Okay. 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 Now m less than 1. What does it mean? That means flow is subsonic. Okay. And what is the condition? Area is decreases. Okay. Okay. Let this be the condition. Okay. Area is decreasing. Okay. If area will decrease, then what will be the condition for velocity? Velocity will increase. And what is the condition for pressure? Pressure will decrease. Okay. This is for nozzle. Some kind of example I just given. Okay. And how this relation arrives? P plus 1 by 2 rho v square plus rho g s equal to constant. This is your Bernoulli's equation. Okay, so here you can see velocity and pressure are what? Inversely proportional. Okay, and how A and B are related? Okay, so for that you have to apply continuity. Okay, A1 V1 is equal to A2 V2. That means A is inversely proportional to velocity. Okay, that's the reason when area decreases, velocity increases, and from Bernoulli we just get it that when the velocity increases, the pressure will decrease from this Bernoulli's equation relation. Okay, for the subsonic flow, it should be noted it's for subsonic flow. Okay, it's very simple. Again the C. Okay, everywhere the option will be C both. Okay, that we know, but how it will be, that we just get to know. Okay, so here again m less than 1, that means subsonic flow. Okay, and area increases. Okay, that means if area will increase, that means velocity will decrease and pressure will increase, and this is the example of a diffuser. Okay, same P plus 1 by 2 rho v square plus rho gh is equal to constant. Bernoulli's equation. Okay, so now continued equation we just get to know. Okay, A1 B1 is equal to A2 P2. So A is inversely proportional to your velocity. Okay, so that's why when area increases, the velocity decreases, and velocity and pressure related to the your Bernoulli's equation. And for diffuser case, the pressure will increase and velocity decrease. Okay, so pressure will increase and velocity decrease is the correct option. Okay, let's next question. Okay, for a subsonic flow, what will be the condition? Okay, now for a subsonic flow means, so I just now show you where is the diffuser and where is the nozzle. Okay, so you can see this one is your diffuser. Okay, diffuser means what? It is a divergent passage. Okay, so when there is a we should mention the flow direction, the other is anything can be nozzle and diffuser. Okay, so you see here there is a, in the diffuser means it is a divergent passage is there. Okay, flow diverges. Okay, so for the subsonic flow, this one is your diffuser. Okay, and for the nozzle, and for nozzle means in the convergent passage. Okay, convergent passage will be your nozzle and divergent passage will be your diffuser in case of subsonic flow. Okay, okay. Next question. Now when Mach number greater than 1 and the flow area decreases, then what will be the condition? Okay, straight down the options. Okay, so that means when Mach number is greater than 1, what does it mean? It means it's a supersonic flow. Okay, with supersonic flow and area will decrease. Okay, for supersonic flow we cannot apply the conventional continuity and conventional Bernoulli's equation. Okay, we can apply at least. Okay, because Bernoulli's equation different versions are there. This for the compressible flow, the supersonic mean the flow will be the fluid will be compressible. Okay, not the incompressible fluid. So for that, okay, means Bernoulli's equation, there is two versions of Bernoulli's equations are there. Okay, so there this compressible and incompressible flow, this Bernoulli's equation is applicable. Okay, if in general somebody asking you the question that Bernoulli's equation is applicable for which kind of fluid or which kind of flow, then the answer will be incompressible. Okay, but in general, if they are asking is it applicable for both, then your answer should be yeah, it can be applicable for both. Okay, because now we can see also here velocity and pressure are also inversely proportional according to this also Bernoulli's equation. Okay, the different versions are there. Okay, so now we cannot apply our continuity, we just apply the this for supersonic flow some special equations are there, okay, and these are the one of them. dA by A is equal to dV by V is equal to m square minus 1, okay. So now this is the equation, okay. So here m is greater than 1, okay, supersonic flow, that means m square minus 1 is your greater than 0, okay. So now area is decreasing, okay, area is decreasing, that means your dA will be less than 0, negative, okay. So now we need to find what is dV, okay. So this is your less than 0, this is your greater than 0, okay. So we have to you have to match the LHS, okay. LHS is less than 0 and RHS is greater than 0, okay. If you multiply one negative sign, then negative into positive is your negative, okay. So dV must be negative, okay. So it must be less than 0, okay. That means if dV less than 0 means velocity should decrease, and if velocity will decrease, then pressure will increase, by compressible version of the Bernoulli's equation, okay. So this is what the thing. The option is obviously always C, okay. Similarly, next question, okay. So just quickly go through this question. So here m greater than 1, supersonic flow, okay. Here as compared to the previous question, when Mach number m greater than 1, flow area will increase. Here the area will increase, there it will decrease, okay. So this is the only difference. That means dA will be your greater than 0, okay. m greater than 1, then m square minus 1 also greater than 0. Okay. So now dA will greater than 0, m square will greater than 0, okay. So what will be dV, so that this LHS and RHS should match? The answer should be, it should be greater than 0, okay. So dV is greater than 0 means velocity will increase. If velocity will increase, then what about the pressure? The pressure will decrease, okay. The answer is C. Now for a supersonic flow, what will be the condition, okay. Now I just show you now this two kind of flow, okay. Now here area will decrease, area will increase means what? If when area increases, okay, that means what? It's a divergent passage, okay. If area will increase means it's a divergent passage, okay. So if although area is increasing, but the velocity is also increasing, and in which case the velocity will increase? In the case of a nozzle, the velocity will increase at the exit, okay. So here the divergent passage will be your nozzle, okay, and here you see area will decrease. Area will decrease means convergent passage, okay. So convergent passage, but the velocity is decreasing. Where the velocity will decrease? At the exit. For diffuser the velocity will decrease, okay. So now what is the final conclusion for a supersonic flow? Answer should be A. So for a supersonic flow, the convergent passage will be your diffuser and the divergent passage will be your nozzle. Okay. This is the difference between the subsonic and the supersonic flow. Okay. So now one bow occurs. Okay, it's not the bow and arrow, that bow, it's a different bow. Okay. So this is kind of a shock wave. Okay, this is a special kind of shock wave. This is a kind of maybe one let it be one impactor I will be there. Okay, so and this and the flow will go in this direction, then one streamline will go in this direction. Okay, which will just impact the impactor, and one streamline go in that direction. Okay, and some streamline go in this direction. Okay, and here maybe some backflow will be there. Okay, and gradually the flow will also means infinite, it will be end. Okay, this kind of structure, when you see, this is a kind of bow suck. Okay, because this bow kind of structure is there. Okay, this is bow suck. Okay, this photo I will delete. You can check directly, you just search in the net, your bow suck will come. Okay, so okay, now for this bow suck, what will be the condition? Answer should be D. Okay, for the bow suck, your Mach number should be greater than 1. Okay, and when it occurs at upstream front of a blunt object. Okay, these are the condition for a bow suck. Okay, okay, now a boundary over which physical condition undergo changes is called what? Okay, this is a most common definition of a shock front. Okay, when there will be shocks, there will be shock front. Okay, and this is the most generic question, can be asked anywhere. Okay, in the exam. Okay, shock front. Okay, what is shock front? This happens due to shock wave. Okay, okay, when it undergo, means when it happen, the shock front, when physical conditions of fluid undergo abrupt changes. Okay, when there will be a physical condition of a fluid undergo abrupt changes, then the shock front will come. Okay, and when it happen, when there is a shock wave, okay, because of that shock wave, this shock front will happen. Okay, this is what about shock front. Next question. A shock wave caused by a driver gas is called what? Okay, there will be two kind of gas. One will be driver gas, which will drive the flow, and one gas should be driven gas, which because of that gas, some of the gases are driven. Those gases are called driven gas. Okay, so when a shock wave is caused by driver gas, okay, then it is what it will called. Okay, one thing you should note, that a shock wave cannot be caused by the driven gas. Okay, it should be caused by the driver gas. Okay, Okay, so the answer should be contact front. Okay. This is the shock wave caused by driver gas. Where it observes boundary layer between driver and driven gas. Okay. Okay, now what this contact front will do? Okay, it always the trails the, okay, or follow the shock front. Okay, what we have before you discuss the shock front. What is the physical condition of a fluid undergo the abrupt changes. Okay, and this is happen because of the shock wave. Okay, so this shock front, okay, is there. So this contact front, what it will do? Okay, it just trails the or follow the shock front. Okay, so now next question. Okay, when the fluid flow is discontinuous, what is established? Okay, so this is very tricky question. Okay, when the fluid flow is discontinuous, then you can see this heat is established, pressure is established, temperature established. Okay, okay, flow is discontinuous. Okay, then you can means most probably somebody will think that, oh, if the flow is discontinuous, that means maybe somewhat pressure will be established. Okay, also maybe some volume will be established or something like that. Maybe you will think heat or temperature, you are not going to think. Okay, so if you are thinking pressure, maybe one more option will be, option will be only volume will be there. Okay, so they will just confuse you like this. Okay, so the answer should be the control volume. Okay, if you know the definition of control volume, then you just 1 second will be required to only solve this question. Okay. Okay, so what is the definition of a control volume? It's established around the shock wave. Okay, and what about the fluid? Fluid is discontinuous. Okay, what does this discontinuous means? Entropy will increase over a infinitesimally larger region. Okay, so this is what the case. Okay, so next question. The shock wave that deviate from the arbitrary angle are called what? Okay, a shock wave that deviate from the arbitrary angle are called oblique shock. Okay, or oblique shock. Okay, and if it not deviate from the arbitrary angle, or it's on its perpendicular, it's called a normal shock. Okay. Shock developed due to angle deviation. Okay, when a shock wave forms continuous pattern, it is called what? Okay, this is also one more characteristics of a bow shock. Okay, so answer is B. Shock wave forms continuous patterns. Okay, this is the speciality of also bow shock. Okay, when you see the trailing edge, it's you see that the pattern is always continuous. Okay, there is no discontinuity. Okay, and this is possible because of two things: because the flow is very fast, that Mach number greater than 1, and obviously blunt object is the, because of this blunt object at the upstream, this bow shock is formed. Okay, okay, next question. Okay, shocks generated due to an interaction of two bodies are called what? Okay, if two bodies are there, okay, so obviously that it cannot be a oblique shock, okay, and it cannot be a bow shock. Okay, because I show you in the bow shock only one impactor is there. Okay, and in also oblique shock there will be one angle will be there. Okay, and also there will be only one single object. Okay, there is no two bodies are there. Okay, detonation until now we don't know what is detonation, whatever thing. Okay, so now the only one option left, which is moving shock. Okay, because this already in the question is asked the shocks, so obviously we can just choose it as a any of the shock options, that is A, B, C and C. Okay, so the answer should be moving shock. Okay, and why it is so, we will just see. Shocks generated by interaction of two bodies. Okay, okay, when this thing will happen, when the shock wave propagating into a low pressure region. Okay, 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 so this is not necessarily only a shock wave propagating to low pressure region. Okay, then what about the expansion wave? Okay, shock wave will propagate to the low pressure region. One more question can be made very easily. Okay, two bodies can be a question. Shock wave and low pressure can be a question. Okay, or expansion wave. Okay, propagating into high pressure region. Okay, so there is three questions can be easily formed from this. Okay, one is two bodies, one is shock wave will propagate to low pressure, expansion wave will propagate to high pressure. Okay, so three questions can easily form from this again. Okay, let's go to next question. Shocks generated due to the trailing exothermic reaction is called what? Okay, I told here shocks word is not there. Okay, so here also you see detonation can be a shock. Okay, so that you see. So shocks generated due to the trailing exothermic reaction. Okay, if any kind of shock, okay, if there is reactions are involving, okay, and that reaction will increase the temperature drastically. Okay, so only in that case when this chemical reaction will come into existence, then the detonation will come. Okay, otherwise in the normal fluid flow or the normal shock there cannot be any kind of detonation. Okay, so that is what the trick. Although they mentioned in the question shocks are there, okay, but they should also mention here reactions are also there, and that too exothermic, where the temperature will increase drastically. Okay, very it will be high. Okay, when these kind of conditions are there, they just trick you with the shock, but this is not any kind of shock, this is the detonation. Okay, so the answer is D. Okay. When this detonation will observe, when the shocks generated due to trailing exothermic reaction. Okay. Okay, now this is one definition. Okay, so this reaction came into existence. Okay, trailing exothermic reaction. Okay, one more definition of detonation is there. Okay, when any kind of wave, shock wave, traveling through a medium of highly combustible and chemically unstable medium. Okay, so when the wave traveling through a medium of highly combustible, okay, this is important, highly combustible and chemically unstable medium. Okay, so two more questions can easily form. Okay, detonation will form when dash kind of combustible, okay, maybe low, high, medium, large, something kind of they can give. Okay, large they won't give, high or low or medium, like that they will give, or there is no combustible, like that something option can be given. Okay, now then one more question can be formed. Detonation will be formed when in the which kind of medium? Okay, chemically stable, chemically unstable, okay, or none of these. This kind of one question will be formed. Okay, or chemically neutral. Okay, So the answer is unstable. Okay, so this kind of question can easily also form 2 more questions. Okay, so okay, okay. Okay, now now the next questions all are will be the problems. Okay, the MCQ question over. Now the problems. Okay, maybe at last one more MCQ is there, that is also one problem. Okay, so in an aircraft flying at an altitude where the pressure was 35 kilopascal, just a second. Okay, so 24, in an aircraft flying at an altitude where the pressure was 35 kilopascal and temperature minus 38 degree Celsius, the stagnation pressure measured was 65.4 kilopascal. Okay, now calculate the speed of the aircraft. Okay, this is one question can be asked. Okay, so what are the things given? Simple problems, we just go with procedure. Okay, what are the things given and what are the solutions? Okay, if there is a lengthy question, then don't waste your time in writing given on all these things. Directly you just jump into the solution. Okay, these are some simple questions, so I am showing the procedure. Okay, but in any kind of mains exam, kind of like maybe civil service exam or EAC, okay, IAS examination, there mains examination, there you have to write down in a proper way. Okay, how I am writing, like that you have to write down. Okay, or in any of your semester exams, okay, you have to write down like this. Okay, so P equal to 35 kilopascal, T minus 38 degree Celsius equal to minus 38. You have to convert it to Kelvin. Okay, always remember all kind of this week 2 whatever the assignment question will be there, you should always remember that you should convert always into Kelvin. Okay, why? So I'll show you why. Okay, so 38 plus 273 equal to 235 Kelvin. So PS stagnation pressure is your 65.4 kilopascal. Okay, so now the fluid is air. Okay, so aircraft will always fly through air. If the fluid is not mentioned, you should assume it is air because it can't fly in water. Okay, so it yeah, but nowadays it can be possible anything, but okay, but if in the question it is asked, so you have to write down air. It will just assume as it as air, then just whatever the property you should remember for air. That's the reason I initially told you should remember all of these properties. Okay, what is gamma, what is specific gas constant, what is the universal gas constant, everything you have to remember. Okay, because in the question, you see in the question nothing is mentioned. Okay, if you remember it, then only you can solve the problem, otherwise you can't solve the problem. Okay, so velocity of sound. Okay, let it be c. Okay, and the formula is c is equal to square root gamma r t. Okay, now I just told you why you convert it into Kelvin, because here you see r of the air, it's in the unit of joule per kg Kelvin. Okay, so denominator Kelvin is there. Okay, if the denominator Kelvin is there, and here also you have to convert it to Kelvin. If it is in Celsius, then it won't, means what the unit is not going to match. Okay, so that's the reason you should convert into Kelvin. Okay, your temperature. Okay, then you put it in the formula. Okay. Just substitute the values. Okay, when you substitute, the answer should be 307.28 meter per second. Okay, this is your C. Okay, now let's go for your PS. Okay, stagnation pressure. PS is equal to P into 1 plus gamma minus 1 by 2 into m square. This formula you should also remember. Okay, so PS already given 65.4, P also given 35, 1 plus gamma also I just told 1.4 for air divided by 2. M we need to find out. Okay, 1.4 by 0.4. Okay, so you have to solve it. I just directly write down. Okay, M is equal to 0.988. Okay, and what is Mach number? Mach number is your actual velocity of flow divided by the sonic velocity of the flow. Okay, so V is equal to MC. So M is equal to 0.988 into 307.28. Okay, answer is 303.85 meter per second. Okay, so this kind of question can be asked. Okay, this very small questions. Okay, I also go to, because here you see here in this one question, two question I just done. One, they gonna ask you velocity of the sound. Okay, only this much will be one question. Okay, then they can ask you what is the Mach number. That is also one question. And then they can also ask you what is the velocity, actual velocity. Okay, three question can easily form. Okay, I directly solve three question. Okay, so now next question. Air is expanded reversibly and adiabatically in a air is expanded reversibly and adiabatically in a nozzle from 13 bar and 150 degrees Celsius to a pressure of 6 bar. The inlet velocity of the nozzle is very small and the pressure occurs under the steady state flow conditions. Calculate the exit velocity of the nozzle. Okay, so this is what the question. Okay, let's go for the solution. So what are the things given? P1 is equal to 13 bar, T1 is equal to 150 degrees Celsius is equal to 150 plus 273 is equal to 423 Kelvin. P2 is equal to 6 bar. Okay, C1 is equal to 0. Why? Because it's written inlet velocity is very small. Okay, here it's written. Okay, so now what we need to find out? Exit velocity. Okay, so here also one thing also given, q is equal to 0 and w is equal to 0. Why? Q 0 for adiabatic condition, and w 0 for what? Reversible expansion given. Okay, and z1 is equal to z2. This is the assumption we have to make. Okay, so this will be your nozzle. This dashed line means adiabatic. Okay, so let's now go for the solution. Okay, so in all this kind of question we will always apply the energy equation. Okay, because everything is taken from energy equation, so in this kind of question always you apply the energy equation. By applying energy equation at 1 and 2, we get m into h1 plus c1 square by 2 plus gz1 plus q is equal to h2 plus c2 square by 2 plus gz2 plus w. Okay, so what are the things is 0, q 0, w 0 and c1 0. Okay, okay, so now let's solve. So now this equation now reduces to, because mm get also cancelled, so h1 is equal to h2 plus c2 square by 2. Okay, c2 square twice of h1 minus h2. Okay, so or directly you can write down square root of 2 into h1 h2 is equal to square root of 2 into cp into t1 minus t2. Okay, so this is the formula for c2. Now T2 by T1 is equal to P2 by P1 gamma minus 1 by gamma is equal to, what is P2? 6. Okay, it's already given, all these things are given already. 6 by 13 to the power fuel is here, 1.4 by 1.4, 1.4 minus 1 by 1.4. This value is 0.8013. Now T2 will be 423, which is your T1 into 0.8013. Okay, so what is T2? 339.16 Kelvin. Okay, now what is C2? Two into Cp. You should always remember Cp should be in joule per kg Kelvin, not in kilojoule per kg Kelvin. Okay, otherwise the answer will be wrong. Okay, into 423 minus 339.16. Okay, so C2 is equal to 410.509 meter per second. Okay, so here you see again in this question 2-3 question can be asked. Okay, so they will ask you that what is T2. Okay, so T2 they can only, they will stop from T2. Okay, they don't go for your what about C2, nothing, they don't go directly in this formula. T2 by T1 equal to P2 by P1 gamma minus 1 by gamma, isentropic flow. Okay, so directly through this formula you can directly find out T2. Okay, so this is one very small question they can ask. Then if they will ask C2, then you have to include all these things and they can find out. So this two more means one more question can be asked. Okay, okay, next question. Okay, air enters a frictionless adiabatic converging nozzle at 10 bar and 500 Kelvin with negligible velocity. The nozzle discharges to a region at 2 bar. If the exit area of the nozzle is 2.5 centimeter square, find the flow rate of air through the nozzle. Assume for air Cp equal to 1005 joule per kg Kelvin and Cv equal to 718 joule per kg Kelvin. Okay. Okay, now just write down what are the things given. Given is P1 is equal to P1 equal to 10 bar, T1 is equal to 500 Kelvin, C1 equal to 0. Okay, why? Because it's written negligible velocity. Okay, so what is P2? P2 2 bar. What is A2? 2.5 centimeter square is equal to 2.5 10 to the power minus 4 meter square. 1 for your inlet, 2 for your exit. Okay, then what else given? Cp 1005 joule for kg Kelvin, Cv 718 joule for kg Kelvin, flow rate of air is equal to Q of air. We need to find out. Okay, also air is there means gamma is equal to Cp by Cv is equal to 1.4. Okay, let's go to the solution part. For the isentropic process, one to two in the nozzle. Okay, what is isentropic? Or why isentropic? Because it's written frictionless adiabatic. What is frictionless? Isochoric process. What is isochoric process? Is reversible process. Okay. Okay, frictionless means reversible. Okay, so same T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. Okay, okay, so what is T2? Then P2 by P1 into gamma minus 1 by gamma into T1. Okay, 2 by 10 to the power 0.4 by 1.4 into 500. Okay, so what is T2? T2 is equal to 315.69 Kelvin. Okay, so now again apply the energy equation. Okay, I just directly write down because you see here C1 is equal to 0. Okay, Z1 is equal to Z2, assume. Okay, and this is given. Okay, and Q is equal to 0 adiabatic. Okay, and W is equal to 0 for reversible or you can assume it as a nozzle. Okay, for nozzle there is no work done. Okay, This will be easy for you to understand. Okay, so energy equation for, okay, if you apply these assumptions, okay, this condition when you apply to the energy equation, okay, then you get as H1 is equal to H2 plus C2 square by 2, okay, and C2 will be your 2 into H1 minus H2 square root, okay, equal to 2 into Cp T1 minus T2, okay, square root. So C2 will be here 2 into 1005 500 minus 315.69, okay. So when you solve it, you will get C2 is equal to your 608.65 meter per second, okay. Okay, now what is the flow rate of air? Is equal to Q is equal to A2 C2 is equal to, what is A2? 2.5 10 to the power minus 4 608.65, okay. When you solve it, you will get 0.1521 meter cube per second, okay. Okay, so this is the answer, okay. Now next question. Helium gas at 5 bar and 75 degrees Celsius enters a convergent nozzle with negligible velocity and expands isentropically into a space at 3 bar. Calculate the mass flow rate per square meter of exit area for helium. Cp equal to 5.19 kilojoule per kg Kelvin and gamma equal to, gamma for the helium is 1.667, okay. So these are the things given. So this kind of big questions, okay, we don't need to write down anything, directly in the solving we just get to know what are the things given or all these things, okay. Okay, so what are the critical conditions? First of all, we just see. Okay. Okay. Critical conditions. Pt by P naught. T for critical. Okay. 2 by gamma plus 1 divided by, to the power gamma by gamma minus 1. Okay. So here P naught will be your P1, which is equal to 3 bar. Okay, so you know gamma 1.667, so 2 divided by 1.667 plus 1 to the power 1.667 divided by 0.667. Okay, that is equal to 0.487. okay, your PT by P naught. Okay, now what is then PT? 0.487 into 3. Okay, is equal to 1.4613 bar. Okay, which is less than P2. Okay, what is P2? 3 bar. Okay, that means when your PT is less than your P2. Okay, so then what will be the case? Okay, then the nozzle will not be choked. Okay, if it is choked, then no need to solve this question. Directly you can write down the nozzle will choke. Okay, no need to solve it also. Okay, so here nozzle is not choking. Okay, that means the gas can expand. Okay, okay, so this is what the case. Okay, so now next what we can now solve. Okay, same way you apply T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. It implies T2 equal to T1 into P2 by P1 gamma minus 1 by gamma. T1 348, P2 3, P1 5. Okay, 0.667 divided by 1.667. Okay, so T2 will be your, if you solve it, you get it as 283.67 Kelvin. Okay, okay, now in the question it's given Cp is equal to 5.19 kilojoule per kg Kelvin, gamma is equal to 1.667. Okay, we know gamma is equal to Cp by Cv. Okay, then what is Cv? Cv will be your Cp by gamma. Okay, which is equal to 3.11 kilojoule per kg Kelvin. Okay, so now you know Cv and you know now Cp. Then what will be your R? R is equal to Cp minus Cv. 5.19 minus 3.11. Okay, one thing you should note. Okay, some question like this, helium gas. Okay, if you know the value of what is the R, specific gas constant for the helium gas, you directly put and solve the question. Okay, then whatever the answer you will get, that will be absolutely wrong. Okay, so when in this kind of question, when they are supplying the value of Cp and they are supplying the value of gamma, that means they want you to do the find that you have to find out the value of R. Okay, specific gas constant. Okay, so that's the reason I am now calculating the R, specific gas constant. Okay, then we can substitute this value. Okay, so when you solve it, you get it as 2.08. Okay, kilojoule per kg Kelvin. Okay, so now we have R. Okay, okay, so why we need R? We need to find out the density. Okay, and why we need density, that I will show you. Okay, density at the exit. Okay, what is the density at the exit? We just apply the ideal gas equation, ρ2 divided by P2 by RT. Okay, which P is equal to rho RT in according to ideal gas equation. Okay, so which is 3 into 10 to the power 5. Okay, convert all into SI unit, don't put any kilojoule quantity. Okay, temperature is your 283.67. Okay, now when you solve it, you will get as 0.51 kg per meter cube. Okay, okay, so here again you have to apply the energy equation. Okay, so energy equation at 1 and 2. Okay, for what are the condition? For Q is equal to 0, W is equal to 0, Z1 is equal to Z2, and C1 is equal to 0. C1 is equal to 0 given, Z1 is equal to Z2 assume. Okay, and Q equal to 0 means isentropic condition. Okay, why isentropic Q equal to 0? Because isentropic means reversible adiabatic. Okay, so adiabatic means Q equal to 0. So that's the reason why isentropic process, your Q equal to 0. Okay, W equal to 0 for two reasons. Okay, first, reversible expansion, that time I am telling this. Okay, or it can be, we can see it as a nozzle. For nozzle, it is not doing any kind of work. Okay, so also W equal to 0. Work done is your 0. When you apply all these things in your energy equation, then it reduces to H1 is equal to H2 plus V2 square by 2. Okay, you can write down V2 or C2, whatever. Okay, no same meaning. Okay, here I think we write down C. Okay, so let's write down here also C. Okay, so then what is C2? 2 into H1 minus H2 is equal to 2 into Cp T1 minus T2. Okay, so next just substitute the values. Your C2 will equal to 2 into 5190. Okay, Cp should be converted to joule per kg Kelvin. 348 minus 283.67. Okay, so C2 equal to 817.16 meter per second. Okay, the mass flow rate per square meter of exit. Okay, okay, so what does it means? That is m by a2, because exit area. Okay, which is equal to rho 2 v2. Okay, that is equal to, what is rho 2? 0.51. what is v2? 817.16. and when you solve it, you get as 416.7516 kg per second meter square. Okay, so okay, so now you see this is some kind of lengthy question. Okay, but in this kind of question it can be asked, many questions can be asked. One is they can ask you what is T2 first. Okay, they can ask you what is R. Okay, what is T2, what is R. Okay, these two first two, this can be all are short questions. Okay, so next they will ask you what is rho 2. Okay, next question they will ask you what is C2. Okay, and the next question they will ask you what is mm or what is m by a2. Okay, so these all questions are single questions which we just solve as a all in a one question. Okay, one more question only left, then we close the section. Okay, air from a reservoir is to be passed through a supersonic nozzle so that the jet will have a Mach number of 2. If the static temperature of the jet is not to be less than 27 degrees Celsius, the minimum temperature of air in the reservoir should be what? Okay, So this is what the question. Okay, some options are there. Okay, so this question means whatever the previous question we just see. Okay, these all the question can be also MCQ questions. Okay, some small short question they will form. Okay, and they will ask you in form of these options. Okay, so this is what the idea. So that I just directly solve the long question so that it will be easy for you when they directly it will come the small short question if it will come. Okay. Okay. Okay, what is the answer? Okay, so air from a reservoir is to be passed through a supersonic nozzle so that the okay. So now you see what is the Mach number M. First of all, we see what are the things given. Mach number is equal to 2. Okay, T2 is equal to 27 degrees Celsius. So 27 plus 273, 300 Kelvin. Okay, so now its air is given. Okay, so gamma of air 1.4. Okay, so now how we will relate the two temperatures? Okay, because they will ask you what is the question they asked. Okay, air from a reservoir is to be passed through a supersonic nozzle so that the jet will have a Mach number of 2 if the static temperature of the jet is not to be less than 27 degrees Celsius. The minimum temperature of air in the reservoir should be, okay, that means T2 is given. Okay, if the static temperature of the jet is not to be less than 27 degrees Celsius. Okay, the static temperature should not be less than means it is the after case. Okay, what is the before case? The minimum temperature of the air in the reservoir should be. Okay, so what is the initial case? In the question you have to understand if it is T2 given or T1 given. Most of the people will think that oh, this is T1, that they will just take the T1 and then put it in the formula and find the answer. Then it's absolutely wrong, and one more option will be also there for them. Okay, which they will choose. Okay, so maybe the answer may be 48.6 or something like that. Okay, so this kind of problems they can make very easily. Okay, so like that also question setters will set the question. Okay, so you will think oh, this question is my answer is correct, it's there in the option, so obviously the answer will be absolutely 100% wrong. Okay, so in the question you should understand which one is C1 and which one is T1 and which one is your T2. Okay, so now you see what is the formula for T1 and T2. How we will relate? T1 by T2 is equal to 1 plus gamma minus 1 by 2 into Mach number square. Okay, now we have to just substitute the values. Okay, T1 by 300 is equal to 1 plus 0.4 divided by 2 into 2 square is equal to 1.8. Okay, so what is T1? T1 is equal to your 300 into 1.8. Okay, so T1 will be your 540 Kelvin. Okay, is equal to 540 minus, you should know that there is no option 540. Okay, because you have to convert it into what, degree Celsius. So the answer should be 267 degree Celsius. Okay, This is what the answer. So answer is C. Okay. Okay. That's it for the today's section. Okay. So if somebody missed the section or something, okay, you just tell your friends. This video should be uploaded in my YouTube channel, Sumit Sagar Hota. Okay. The previous video, some left side, some crop is there, some problem is there. I think from this time onwards, I will fix this problem. Okay. First lecture, that problem is there. I think this video I will sort out this problem in this YouTube channel. I have already uploaded the lecture 1. Okay. This lecture 2 will also be available in my YouTube channel. Okay. Just if anybody don't know, coming to first time to this class. Okay. So just check it. Okay. In my YouTube channel. Okay. And share your friends. Okay, if they have any doubts, you can ask also in the comment section in the YouTube also. Okay, or you can ask in the question and answer forum. Okay, and any question, any doubt also there you can ask also in question and answer forum also in the NPTEL also you can ask. Okay, so you can just end the section. Okay, thank you very much for joining. Okay, and okay,
Thank
good
you,
night.
sir.
Okay.